Okay, I will record the class. Okay, now we were learning inert gases. Inert gases, physical properties we had finished, and we had to start with the chemical properties of inert gases. Anybody remembers the physical properties? What all we said? What are the physical properties?
Andy, what's this, Andy? Andy, today's what's topic we're gonna start with?
No, noble gases we were doing. No, we'll finish it off P block
Okay.
today.
Andy, they
Okay.
are
Okay.
monoatomic.
Yes, they are colorless, tasteless, odorless gases. They are monoatomic.
They are rarely soluble in water.
They are sparingly soluble in water. And what will happen to the solubility as you increase the atomic number?
Creases.
It increases. Why? Why it increases? Because as the size of the atom increases, induced dipole increases. Bigger the size, the charge separation is more in the atom. So water will induce polarity in the atom of the noble gas, and that induced polarity increases. Water is a dipole. Dipole will induce dipole in the atom, and that increases because of the size. So solubility increases. Dipole, induced dipole interaction increases. What will happen to melting and boiling points? Melting and boiling points?
Andy, they are low, Andy.
They are very
melting
low. They are all gases. But as you increase the atomic size, they have only van der Waals force of attraction. Okay? They have only van der Waals force of attraction, which is very weak. But as the size increases, you know that van der Waals force depends only on the size. And that as the size increases, van der Waals force of attraction increases. So if it increases, melting and boiling point increases. And helium is the substance having the lowest known boiling point, 4.2 Kelvin. Okay, till that we studied. Now chemical properties, listen to me very carefully. Here structures, everything is very important. Now you can see the board now properly. Okay, now chemical properties, are they chemically reactive? First of all,
The light of least
They are
reactive.
not
No,
reactive.
they are not reactive. Why they are not reactive? Why they are not reactive?
Andy, they have a complete field.
Very good. First reason, they have stable electronic configuration, completely filled electronic configuration. 2, they have very high ionization enthalpy. You cannot remove the electron. 3, they have very high positive electron gain enthalpy. That means they neither wants to lose nor wants to gain an electron. So because of all these factors, they are inert. They do not participate in chemical reactions, chemically not reactive. Until recently, till 1962, people thought that they will not react at all, they will not form any compounds. But in 1962, a scientist by name Bartlett, see here what happens, you know that helium, neon, argon, krypton, xenon, radon. Okay, so you know that as you go down the group, ionization enthalpy, what will happen? Ionization enthalpy, as you go down the group, ionization enthalpy decreases because of the size. It is easier to knock off the electron. So it's very difficult to knock off electron from these 4. Radon is a radioactive element. So only the element which can form compounds is xenon here. because of the very low ionization enthalpy. So what happened was, a scientist by name Neil Bartlett, what he did was, he took a compound. This is platinum hexafluoride. Platinum hexafluoride, which is a gas, and when he reacted that with oxygen, platinum hexafluoride oxidizes oxygen to forming a compound. This is also important. A compound called dioxygenyl hexafluoroplatinate 5. Why it is 5? I will teach you the nomenclature in coordination compounds. So dioxygenyl, this is a solid. These two are gases. It forms a crystalline solid, ionic solid, dioxygenyl hexafluoroplatinate 5. So what he thought was, oxygen, the ionization enthalpy of oxygen is 1175 kilojoule per mole. 1175 kilojoule per mole, quite high, but so he has oxidized oxygen to O2 plus, that is, he has removed one electron from O2. So when he observed that, he found that xenon ionization enthalpy is comparable to the ionization enthalpy of oxygen molecule. So it is 1170. Then what he thought was, if it can, PTF6 can oxidize O2 to O2 plus, why can't it oxidize xenon to xenon plus? Why can't it oxidize that? So then what he did, similarly, he took PTF6 and he reacted with xenon. When he made them react, immediately they reacted, forming xenon hexa, actually orange crystalline solid. In some book they have given it as red. Red is also okay. They have asked the color also, they have asked the name, they have asked the structure. Everything is very, because this is the first inert element compound discovered. Xenon hexachloroplatinate 5. This is the compound first discovered. Okay. Later on, many compounds of xenon were synthesized. Many compounds of xenon are synthesized, especially with more electronegative atoms like oxygen and fluorine, like xenon, XeO3, O4, F2, F4, F6, XeOF2, O2F2, OF4, everything, all the compounds are discovered, xenon with oxygen and fluorine, and a combination of oxygen and fluorine, oxyfluorides also. So many compounds are synthesized now. And krypton, later on they found that it forms KrF2. Okay. This is the only stable compound of krypton, and compounds of radon they have identified by the tracer technique. Okay, by the tracer technique they have been identified, and helium, neon, argon, they do not form compounds at all. Very high ionization enthalpy, so they do not form compounds at all. So now the only element which forms considerable number of compounds which we can study is xenon. So we are going to study the compounds of xenon, that is xenon fluorides, xenon oxides, xenon oxyfluorides. All the three we are going to study. Now I will just write the preparation properties. You can just write it down in the rough sheet. I will send the notes later. Okay. Now we'll start with xenon fluorides. Every reaction is important. They have asked, fill in the blanks, or how it is prepared, like that they have asked so many times. Xenon, very important. I am telling you, learn it thoroughly. Today only I will send the notes. Learn it thoroughly. Okay, xenon fluorides. Now xenon will form a number of fluorides. XeF2, XeF4, XeF6, all these compounds are formed. How they form? When you change the amounts of xenon and fluorine. Depending on the relative amounts, you get the different compounds, and depending on the conditions also. So I will write it. I will show you how to remember it, and I'll tell you how to write the equation. So xenon, it will react with the fluorine. First listen to me and then you can write it. Xenon plus F2 giving XeF4. Xenon plus F2 giving XeF6. Now what you do is, you are going to first learn it and then don't look at the board, write it. Okay. First, all are gases. All the reactant xenon and fluorine are gases. And the compound formed is solid. In all the three cases, compound from it solid. They are volatile solids, but they are solids. Now, how do I remember? Xenon and fluorine, if you take 2 in the 2:1 ratio, you will get XeF2. If you take 1:5 ratio, you get XeF4. If you take 1:20 ratio, you get XeF6. 2:1, xenon more and F2 less, you get XeF2. Xenon plus F2 1:5, you will get XeF4. Xe plus F2 1:20, you are going to get XeF6. Then all of them are done in nickel tube. Nickel tube. Okay. Now, next is, you remember 673 Kelvin, 873 Kelvin, 575. This is very important. Temperature, pressure, very important here. 673, 873, 575. Then pressure 1 bar, 6 to 7 bar, 60 to 70 bar. Very high pressure here. I repeat, first you write XeF2, XeF2, XeF4, XeF6. Then put all gases here, solids here. Then ratio 2:1, 1:5, 1:20. Then all are done in nickel tube. Then temperature 673 Kelvin, 873, 575. Pressure 1 bar, 7 bar, 6 to 7 bar, 60 to 70. Easier to remember. Actually this is 6 to 7. This is 60 to 70. This is 1. You can remember. Easier to remember. Is it right? Are you able to understand?
Yes, aunty.
Okay. Now I will not allow you to see the board. Write it in the sheet. Write all the very important. I am telling you. You have to learn it thoroughly. Write it. Write the 3 equations. Write the ratios, temperature, pressure, everything. Write it neatly. I will not show you the board and you write it. You could recollect without looking at the board.
Yes, aunty. Pressure alone is a bit confusing.
Tell me Bharadwaj.
Pressure alone is tough to remember, aunty.
No, tough. 1 bar 6 to 7, 60 to 70. Will you remember?
Yes, Auntie.
Okay. Krupa, read out first reaction.
Okay, xenon plus F2
Ah,
in pressure 1 bar gives XeF2.
what else did I say about the amounts? You have to give the ratios of xenon and fluorine.
Auntie, I actually got disconnected for a while. Can you just tell me what you're doing right now?
Pardon?
I actually got disconnected for a while. Can you just tell me what you're doing right now?
I'm not able to hear you. Not clear, Avik.
Can I type, Auntie?
Yeah. You are not clear. Your voice is not. No clarity is not there. I'm not able to hear you. What you are saying?
Auntie, can you hear me right now?
Huh?
Can you hear me right now, Auntie?
Tell me.
Auntie, I told I got disconnected for a while. I was just asking if you could tell me what you're doing right now.
You got disconnected. Okay. See, we were learning the preparation of xenon fluoride. I asked you. I explained it. Asked you people to write it down in a rough sheet, and I wanted you to
Auntie.
repeat.
That equation, Auntie. You mean that
Equation.
xenon equation.
Yes.
Okay.
Krupa,
I'll
I
try.
asked her to do the first one. So she said Xe plus F2. What else did you write, Krupa?
Into pressure 1 bar and the product is XeF2.
Okay, temperature?
675 Kelvin.
673.
673.
673. And xenon is more there. 2:1. Fluorine is 1.
Yes, Auntie.
Okay. Rishi, tell me the second one.
I didn't get time to remember. 1 second.
You don't need so much time to write, Rishi. It hardly takes 1 second.
I forgot the reaction. I'm trying to remember.
You should
Maybe the
concentrate.
second one, Auntie.
When once you see, if I say something, you should register it just as it is. It should be registered on your mind properly. XeF2, Xe plus F2, all the three reactions remain the same. I have not balanced it anyway. It is 2F2 and 3F2. It's very easy to balance it also. It's not difficult. See, xenon 2, F2 1, 2:1, 1:5, 1:20. All are on nickel tube. Temperature 673, 873, 575. Pressure 1 bar. You start with 1. Remember 1 bar, 6 to 7 bar, 60 to 70 bar. Is that okay?
Yes, Auntie.
You are all young man. Once I say, you should register it immediately.
Okay, got it, Auntie.
Got it. You should never forget this.
Yes.
Definitely they will ask this. Xenon fluorides. Okay. Now, xenon, what is that? F6 can also be prepared by treating XeF4 with O2F2, dioxygen difluoride. You are going to get XeF6 plus O2. If they give you this reaction also, you can write. So, you can prepare
Auntie,
XeF6. You can prepare XeF6 by treating XeF4 with O2F2. Write the reaction. XeF4 plus O2F2 giving XeF6 plus O2.
Auntie, your internet is like weak, Auntie. Video is not clear.
Video is not clear. I'll take a pic and send.
Yes, Auntie.
Wait. I'll take a pic and send. I have sent a pic. Okay. So, you can also prepare XeF6 by treating XeF4 with O2F2. There are so many so though noble gases is a very very small thing, small chapter compared to other three groups, there are enough questions asked in that. Okay, learn it thoroughly. Okay, so this is the preparation. Now we'll start with the properties of this. Properties also learn it thoroughly. Now all of them are colorless crystalline solids. All the xenon fluorides are colorless crystalline solids. Register thoroughly when I'm saying. And they all sublime at room temperature. That is, at room temperature 298 Kelvin, 25 degrees centigrade, they all become gases. What is sublimation? Direct conversion from solid to gas. It is called sublimation. So they sublime at 298 Kelvin. Third, they are very powerful fluorinating agents. They are very powerful fluorinating agents. Now here we have reactions here. It is not clear, board. Board is not clear, kid.
No, aunty.
No, auntie. The
No,
photo
auntie,
you
it's
sent
very
is very
blurred.
Oh. Okay. HCF4, I will orally say it. HCF4 plus SF4 sulfur hexafluoride, right now HCF4 plus SF4 will give you SF6 plus Xe. I have not balanced it, you have to balance it.
And the HCF4 plus
HCF4 plus SF4 will give you SF6 plus Xe. That means they are powerful fluorinating agents. That is, they add fluorine to the other compound. I have not balanced it. 2 and 2 balanced. Now another reaction, HCF4 plus platinum, PTF4 plus Xe. I repeat the reactions. First reaction, HCF4 plus SF4, 2SF4 giving 2SF6 plus Xe. They have fluorinated SF4 to SF6. Then second, HCF4 plus platinum giving PTF4 plus Xe. I will try to erase it more, my board. I think it may become more clear then.
Auntie, actually internet problem.
yes, auntie.
Internet problem. But audio is clear, no?
Audio is fine.
Audio is
somewhat
clear.
auntie.
And for me, internet is showing all the lines, man. It is showing good connection only. I don't know why the board is not clear. Okay. Now, next, this is their powerful fluorinating agents. Next, they are this is also very important. They are hydrolyzed by even small amounts of water, trace amounts of water. So, HCF2, write down HCF2 plus water giving Xe plus HF plus O2. HCF2 plus water giving Xe plus HF plus O2.
Auntie, is there any temperature, auntie?
Pardon?
Do we need to mention the temperature, auntie?
No. You just put water, they get hydrolyzed. HCF2 plus water, balance it. Balance it. And HCF4 plus water, Xe plus XeO3 plus HF plus F2. So remember here, xenon difluoride will give you xenon HF plus O2. Xenon tetrafluoride will give you XeO3 HF plus F2. F2 if the water is small amount. Oxygen if it is larger amount. I will tell you that later. Write down. XeF4 plus H2O giving XeO3 plus HF plus F2. This reaction is important because you are learning the preparation of xenon trioxide, oxide of xenon. Write both the reactions and balance it. If you can't see, you tell me, I will read it out again.
Auntie, what's the last reaction, Auntie?
Last reaction, XeF4 plus H2O.
Plus H2O, Auntie.
H2O.
Okay, fine, Auntie. Fine, Auntie.
Now you balance it. I'll just get a clean cloth so that I can erase the board neatly. Board clearly let out. Because I need you people to see the board because I need to write the structures for very important xenon structures. I need the board neatly. Over. Who will tell me the balanced equation? First one, XeF2 plus H2O giving XeHFO2. Who will balance it?
Ma'am, I cannot see the board, ma'am. It's very bright. I can't see anything on the board.
You can't see anything. XeF
It's
plus
probably
H2O. Write down XeF2 plus H2O giving Xe plus HF plus O2. Balance it. Balance it. Rishi, tell me the balanced equation.
ma'am, XeF2 plus.
XeF2 plus H2O.
Ma'am, what does it give?
It gives Xe xenon plus HF plus O2. Balance it, Rishi. Tell me.
Auntie, are they kind of explosive, Auntie, this particular reaction?
Pardon?
Water? Are they kind of explosive with this reaction
Yes.
with water, Auntie?
Yes, they are very explosive with water. They form explosive solids. X is an explosive solid.
Auntie, Auntie, board is not clear, Auntie. I sent in group also, Auntie. See the group, Auntie, the photo.
What you said, man?
Photo, Auntie. Video is not even clear.
Ma'am, can you send the photo of the board so that I can see what the equation is?
Yes, Auntie, that's exactly how the board is, Auntie. The one which Bharat
Like
has
this
sent.
only it was, Auntie. Nothing is visible.
Now I have sent the reactions, balance it. Yeah. Board, that's why I was cleaning the board, I think.
Ma'am, for the first one, it's 2 XeF2
Very
plus 2
good.
H2O giving 2 Xe plus 4 HF
Very good.
plus O2.
Plus O2. Very good. Super. Second one, who will tell me? Good, Rishi. Very good. Well done. Second one, Abhik, Bharadwaj, Krupa. Okay, I will balance it. 2 XeF4, 3 H2O giving Xe plus XeO3 plus 6HF plus O2. 2XeF4 plus 3H2O giving Xe plus XeO3 plus 6HF plus F2. Okay. Now I will erase. I think if I write now after erasing, board may be very clear. Because board was not clear. I observed. When you sent the photo, I observed. Board itself is not clear. Okay. Now I will tell you what is the next reaction. XeF2, XeF4, XeF6. Okay. Now here, if you see, I will treat it with PF5, SbF5 and MF. M is a metal, alkali metal. Alkali or alkaline earth metal. Sodium, potassium, calcium, all that. Okay. Now, what it does is, this PF5 is a fluoride ion acceptor. Fluoride ion acceptor. So, that means it will take one fluorine from this, from XeF2. So, what is left now? XeF is left. That will have plus charge and PF6 will have minus charge. So, PF5 is a fluoride ion acceptor. So, XeF2 will give one fluoride ion to it. So, that this becomes plus charge, cationic species. XeF plus and this will become PF6 minus, anionic. Even here, XeF4 plus SbF5, similarly it will give one fluoride ion. So this becomes XeF3 plus and SbF6 minus. This is also a fluoride ion acceptor. Now, whereas if you take a metal fluoride, this they have asked in the exam. Whereas if you take a metal fluoride like potassium, calcium, alkali and alkaline earth metals, they are fluoride ion donors. They do not accept, they donate. So that they will form M plus XeF7 minus. Where M is sodium, potassium, calcium, all that. You understand this? So, they react with fluoride ion acceptor forming cationic species and fluoride ion donors forming anionic species. This is forming an anion. You are able to see the board?
No, auntie, nothing is visible.
Huh?
Nothing is seen, auntie.
Now I have erased it and it is very clear, man.
Auntie, it's actually not the fault of camera or this thing, the writing on the board, auntie. It's internet, auntie. Your board is actually clear only, auntie. It's only the network issues.
Okay, now I have sent the pic. See the pic. See the pic now. Sodium, potassium, all alkali metals, rubidium, cesium, all that. So, if you treat it, you are able to see the picture now?
Yes, auntie, picture we can see.
Okay, so they will react with fluoride ion acceptors forming cationic species, fluoride ion donors forming anionic species. If they give you any alkali metal, you have to write like this. Okay, write the reactions, all the three reactions, write it. All the three reactions, write it in your book or paper, whatever you have kept.
Auntie, what did you write in the place for this sodium, calcium, and all can come now? Auntie, potassium.
Rubidium, cesium, all the alkali metals.
Okay.
All the alkali
What
metals.
symbol is that? Did you write actually M and something M plus or something?
M plus.
The last
Yeah.
reaction.
M
So that
plus.
N can be of potassium, calcium. or
M can be sodium, potassium, rubidium, cesium. Anything.
Okay.
That's easy. But you should know that if they give you phosphorus or antimony, you have to write it as like this. And if they give you alkali metal, you have to write it like this. So many reactions are there. So actually it is such a small chapter, but many reactions are there. So you have to be little careful. You have to learn properly. Okay? Wrote all the 3 reactions, kids?
Yes, Auntie.
Okay.
Yes, auntie.
Now we will learn xenon oxides. Xenon oxide. It forms XeO3 and XeO4. 2 oxides. Trioxide and tetraoxide. How they are formed? They are formed by the hydrolysis of XeF4 and XeF6. XeF4 and XeF6, when you hydrolyze, they will form, we have already written this reaction. XeO3 plus HF. Okay? So, if you are not able to see the board, don't worry, I will read it out. Xe, write down because I want you to balance. XeF4 plus H2O giving Xe plus XeO3 plus HF plus O2. Ayyo. Sorry, Pa. There was some internet. This one. Okay. Now I will write another 2 reactions. XeF4 plus water. XeF4 plus water. You try to balance the equations, these 2 equations. Okay. Now, listen here, kids. First listen here. XeF6, if you do complete hydrolysis, you will get XeO3 and HF. If you do partial hydrolysis, depending on the amount, you are going to get XeO2F2, XeOF4. Little confusing. Learn it thoroughly, right? 5 times and learn it thoroughly. So,
Auntie, the board is actually now clear, Auntie.
now clear. Very good. Very good. Because by the time I start the structure, it should be clear. So, xenon oxides are obtained by the complete hydrolysis of xenon tetrafluoride and hexafluoride with water. Complete hydrolysis. So, if you do partial hydrolysis of XeF6, you are going to get 2 oxyfluorides, XeO2F2, XeOF4. Xenon dioxygen difluoride, xenon oxygen tetrafluoride. 2 oxyfluorides you are going to get. Actually, there are many compounds are there, but in the book, in the syllabus, they have not given. XeO3F2 is there, XeOF2 is there. So many are there. So whatever they have given, we will learn that. Okay, so first write down how you prepare the oxide XeO3. By the complete hydrolysis you will get oxide. Partial hydrolysis you are going to get these two. Balance all the four now. Balance all the four. First reaction is very difficult to balance. Others, okay, you can balance it. There are four. I'll ask all of you. Be ready.
Auntie, except the first, I did all three, Auntie.
Very good. Tell me the second one.
XeF6 plus 3H2O
Yes.
gives XeO3 plus 6HF.
Yes, very good. Third one.
Me, Auntie.
No, not you. Rishi, third one.
Auntie, can I try the first one, Auntie?
Try first one. Very good. Try.
Just to try, Auntie, I'm not sure. 6HCF4, Auntie,
Very good.
and 12H2O,
Very good. Excellent.
and 4HC and 2XeO3, that should be 2HF, Auntie, and 3O2.
24.
Sorry, 24HF and
12 to
Yeah, my bad.
24.
and 3O2.
Okay, very good.
3O2.
302. 6 plus 6, 12. Very good. Excellent, Tabik. Excellent. Excellent. Write down the balanced equation. Now, Rishi, you tell me the third one and Krupa will tell me the fourth one.
Ma'am, his third one, XeF6 plus 2H2O gives
Very good.
XeO2F2 plus 4HF.
Very good. Super. Super, Rishi. Fourth one, Krupa.
22 HF and
That's all. Very good. Easy. She got easier. Very good. Excellent. Only the first one is difficult. Like all of them have coefficients. All of them have coefficients. Otherwise, it's very easy. So, XeO3 is a colorless explosive solid and we are going to learn structures of all of them. Very easy. You will enjoy writing the structures. This is the best part in noble gases. Writing the structures. Okay? Shall we start writing the structures?
Yes, Auntie.
Structures, uses. That's it. We have finished the chapter. So, I will erase it now. Now, I will learn the structure. Now, coming to the structure, you know that xenon has got 5s, 5p and 5d. Okay, 5s, 5p, 5d. Actually, what is the number of electrons? It is like this, 5s2, 5p6. Okay, now, first what happens when you have XeF2? Okay, once you listen to me carefully, you can learn it. It is registered. It is that easy. XeF2, it has to form two bonds. So what it will do? One electron from 5p, it will jump to 5d. Here, one electron. So you will have 1, 2, 3 bond lone pair, and this will form bonds with F. So 2 bond pairs. So it will have 3 lone pairs and 2 bond pairs because one electron from here has jumped to this. So totally 5 pairs of electrons. 5 pairs of electrons, it is undergoing, I will write it this, very important is the hybridization, sp3d hybridization. So 5 pairs of electrons, 5 pairs, bond pair 3, lone pair 3, bond pair 2. bond pair 2. This is the hybridization. Now, what is the expected geometry if it has got 5?
The pyramidal.
Huh?
Pyramidal.
Trigonal pyramidal. 3 in like this, 1 up, 1 below.
Yes, aunty.
So, trigonal pyramidal is the expected geometry. Trigonal pyramidal. We will see what is the actual shape. Now, XeF4. Now what happens? One more electron jumps here. One electron already here. One more jumps here. So, it will have totally 1, 2, 3, 4, 5, 6 pairs of electrons. Out of 6, 2 lone pair. These two lone pair and 4 bond pairs. 4 bond pairs. So, if it is 6 pairs, what is the expected geometry? 6 pairs, what is the expected geometry? You know that?
Hexagon.
No,
Octahedral.
octahedral. 4 in one plane, 1 up, 1 below. Okay? Expected is 6 always is octahedral. You will learn more about the shapes in coordination. You will get very much used to that. Now, hybridization here is sp3d2 because one electron has jumped to here also. First only one electron jumped, it is sp3d. Another electron jumped, sp3d2. Now, in XeF6, what will be the hybridization? Another electron will jump. From here it jumped, here it jumped, here also it will jump. So, yes.
And in what at the XC?
XeF6.
F6. Okay.
F6 means you need 6 unpaired electrons. Correct? Am I right?
Yes, aunty.
6 bonds with fluorine, 6 fluorine atoms. You need 6 unpaired electrons. So, P3, that is P6, all the 3 of electrons will jump to D3. They will undergo hybridization. So, it is sp3d3 hybridization. So, here only one lone pair of electron, that is 5s, and all are bond pairs, 6 bond pairs. Sorry. Totally 7 pairs of electrons, out of which 1 lone pair and 6 bond pairs. So, if it is 7, what is the expected geometry? 7. We have learnt this. Tell me, where did you learn and what is the geometry? You need to be attentive, more attentive.
P3D20.
Where did we learn? 7. Just now, last class. XX-7. I told you this. If it is 7, it will be pentagonal bipyramidal. 5 in one plane, 1 up, 1 below. Pentagonal bipyramidal. Expected geometry. We will see what is the actual shape. Pentagonal bipyramidal. Okay. So, you remember like this. XeF2, sp3d hybridization, 5 pairs totally, 3 lone pairs, 2 bond pairs, trigonal pyramidal, 1 electron jumps. XeF4, 2 electrons jump to 5d1, d2, so 4 bond pair and 2 lone pair, expected is octahedral. XeF6, all the 3 from P will jump to D, it will be sp3d3 hybridization. 7 pairs, out of which only 1 lone pair and 6 bond pairs, expected is pentagonal bipyramidal. Now, similarly, I will write XeO3. Okay, I will write it in the order so that you will learn it properly. XeO3, it is sp3 hybridization. sp3 hybridization. Now, I will tell you the bond pair and lone pair. sp3 hybridization, there will be 4 pairs of electrons, out of which 3 are bond pairs. It will form with oxygen because oxygen takes 2 electron, double bond O. Oxygen is bivalent. Fluorine was monovalent, only 1 bond. Whereas oxygen will form bivalent, 2 bonds. So 3 bond, 1 lone pair and 3 bond pair. So sp3 hybridization means it should be tetrahedral. sp3 is tetrahedral. Now XeOF2. XeOF2 is sp3 dehybridization. sp3 dehybridization. XeOF4 sp3 d2 hybridization. Remember like this only. In the same order you remember. XeF2 sp3d, XeF4 sp3d2, XeF6 sp3d3, XeO3 sp3, sp3d, sp3d2, XeO2, XeOF, XeOF2, XeOF4. Write it down all of you. Make 1, 2, 3, 4, 5, 6, 7 columns. Make 7 columns.
Auntie, can you send a picture of the board?
Pardon, ma?
Auntie, can you send the picture of the board?
Two, pair. 1 minute, I'll finish it off and then say. Trigonal pyramidal, sp3d. So trigonal pyramidal. I am writing the expected geometry, but it is not the shape observed. Okay. So sp3 d2. So 6 pairs. So how many bond pairs and how many lone pairs? 4 plus 1, 5. 1 lone pair, 5 bond pair. The sp3d2 should be octahedral. Octahedral. Okay, 6 pairs of electrons, out of which 2 lone pair and 3 bond pair. I'll send a pic. You are not able to. You said it is clear.
And it was clear for like just 1 minute or so.
Wait, I will send the pic because you need to learn the structures. That is, it's very important. I have sent it. You write it. You write it without seeing. It is very easy. XeF2, sp3d, XeF4, sp3d2, sp3d3. Then XeO3 you start. sp3, XeOF2, sp3d, XeOF4, sp3d2. You can write it, Krupa, without any, you don't have to see the picture and write. And if you know the number of pairs of electrons, you know what is the geometry. Write it down, because before I write the structure, actual shape observed, actual structure, that is the shape, I will tell you how. I want to erase this because my board is almost filled. That is why. Are you copying, kids?
Yes, auntie.
Okay. Now I will erase it. Anyway, I have sent the pic. I will erase it. Now I will write all the structures. You write it along with me. Write it three times and you will learn. So we'll start with XeF2. Xe. Always remember, lone pair of electrons you write in the equatorial position. Bond pair you write it up and down. Always. So XeF2 has got 3 lone pair, 2 bond pair. So you will write it like this, all the 3 lone pairs, equatorial position, and 1 fluorine up, 1 fluorine down. So I expected trigonal, pyramidal, bipyramidal. Expected geometry is linear. Write the structure, linear. XE, you show equatorial position 3 like this and F1 up, 1 below. Now, XEF4. XEF4, it should be expected is octahedral. Here, octahedral. XE, you write fluorine, all the fluorine like square planar. You write it like square planar. And in the axial positions, write the lone pairs of electrons. So, though expected is octahedral, actual shape is square planar. Square. Very tough questions are asked on this. You have to be very strong in hybridization, number of bonds pair, lone pair, shape. Because they will twist the question properly here. They have asked in the book back only, not the direct structure. They have asked some compound isoelectronic with this. I will discuss it later. Don't get scared. I will discuss it later. Very difficult question it is actually. Then XEF6. XEF6 has got 5 pairs. I mean 5 plus 2, 7 pairs. 7 pairs means pentagonal bipyramidal. But expected is, see how it is written is XEF6 F fluorine, like this you write. Then you have 1 lone pair here. So it should have been straight. It is little bent like this. Little bent because of the lone pair here. It is because of the repulsion. It is little distorted. So you write it as distorted octahedral. Distorted octahedral. Distorted octahedral. Then XEF2 over, write down the formula. XEF2, XEF4, XEF6. XEF6. Then XeO3 now. Actually, it is sp3 hybridization. So it should be tetrahedral. In the tetrahedral, one position is lone pair. So it looks pyramidal. Like this. Double bond O, double bond O, double bond O. This is XeO3 pyramidal. Like ammonia. Pyramidal structure. Now XeOF2. Very interesting structure actually. Xe double bond O F F. So 2 lone pairs of electrons like this. This is XeOF2. I expect trigonal bipyramidal, but it is T-shaped. Because of the lone pairs of electrons, it is T-shaped. Now, just listen to me. If they ask you XeO2F2, just put 1 oxygen over here. If they ask you XeO3F2, put another oxygen here. That's all. All are trigonal bipyramidal only. All are trigonal bipyramidal. Just put 1 more double bond O here and another double bond O here. Now, XeOF4. XeOF4, it is like this. F, you write square planar, F4. Okay. And then what you do is, 1 oxygen up, double bond O, it looks pyramidal like this. This is XeOF4. XeOF4. It is square pyramidal. That's all. Square, and pyramid, square pyramid. It should have been square bipyramidal or octahedral. Square bipyramidal is nothing but octahedral. It should have been that, but because of that, there is one lone pair in the other end. Okay, so it is like this. It's very easy to remember if you remember it systematically. Linear, square planar, distorted octahedral, pyramidal, T-shaped, like we had what is that compound? ClF3, BrF3 we had no. They'll ask you what is isoelectronic. You can give that BrF3 here. Same thing. BrF3 also 3 bond pair and 2 lone pair, like this only. Okay, I will send the pic now. I have finished all the structures. Wait. Now see kids, I have sent all the structures. You could see all the structures?
Yes, Aunty.
Yes, sir.
Learn, see, xenon preparation, xenon fluorides, oxides and oxyfluorides. Learn the preparation and then the structures, very important. Structure, hybridization, number of bond pair, lone pairs, expected geometry, shape observed, everything. Learn it thoroughly. Definite question. Okay, finished?
Yes, Aunty.
Okay. Now, if you are finished, we left to just the last bit in P block. At last, we are coming to the end. That is the uses. Okay. I will just list the uses. I'll give you I'll send you the pic. Your notes. You just copy that. Now, helium. Helium, very important. It is used in filling balloons, which are used in observing meteorological devices. Because it is very light and highly non-inflammable, it is used like that. And liquid helium, because of its very low temperature, it is used as a cryogenic agent. Cryogenic agent which is used in safety devices like protecting safety devices like MRI, NMR. You have heard of MRI scan, they say no? You have
Yes, Aunty.
heard MRI?
Yes, Aunty.
That is magnetic resonance imaging. Okay, and NMR, nuclear magnetic resonance spectrometers. Okay, because of its very low temperature, they use very, very powerful superconducting magnets in that spectrometers. Okay, MRI scanning machine. So to maintain that, they use liquid helium. Okay, there it is used. And you also know that helium is nothing but helium nuclei is nothing but the alpha particle. It is used in nuclear reactors for bombarding. And another thing we studied, that in solutions we studied, that is helium air oxygen mixture is used for asthma patients for breathing, and helium air mixture is used for deep sea diving for breathing, because nitrogen will cause bends. We studied that. Because helium is light, it is mixed in the cylinders, gas cylinders. Okay, these are the uses of helium. Neon, it is very highly, very famously known for neon signs, advertisement. You get that bulbs, no, glowing bulbs, that is neon. Neon mixed with different gases will give you different glows. So it is used to fill discharge tubes and fluorescent bulbs. and it will give you very beautiful colors, all colors. So they are called a neon signs. So they are used in advertising, neon. Okay, and neon is also used in helium neon mixture is used in maintaining devices like voltmeter, rectifiers, all that they are used in maintaining those this one maintaining that. Okay, and neon, where else is used? Okay, that's it. Argon is used in the fluorescent lamps, and neon argon mixture they are used in this one inert atmosphere. Wherever we need inert atmosphere for chemical reactions, we use neon argon mixture, and neon argon mixture also will give you beautiful colors, lights, lamps. Okay, and argon is used in welding also. Welding argon light is used for welding purposes also. Then krypton and xenon, they are used in the minus cap lamp, they are used. Okay, they are used, and krypton is used in measuring the thickness of metal sheets and plastic sheets. Okay, and radon, very important, radon is used in the cancer therapy because it's radioactive, cancer therapy, and it is also used in finding out defects in steel castings. Okay, these are the uses of that. They have asked this also. Uses of inert gases, very important. Especially neon, helium and neon argon also. Radon also. Therapy, cancer therapy, very important. Which is the element used in cancer therapy? You know, which inert gas is used in the treatment of cancer therapy? That is the radon, because it's radioactive. You can kill the cancer cells. Radiations. You can send the radiations and kill the cancer cells. So this completes that's all. Neon, helium neon mixture, safety devices. Neon bulbs are used in greenhouses and botanical gardens. That is also there. Okay, that's all. Xenon and krypton, radon. Okay. So it is used to provide inert atmosphere during welding. So learn the uses also thoroughly. Properly you learn the uses also. Understood? It was interesting. Structures of xenon, fluorides and oxyfluorides.
Yes, Auntie.
It was very, I find it very interesting. Whenever I see any question on that, I feel very excited. It's very nice actually. And you have got 3 in-text questions. I will
Auntie, I have a doubt, Auntie. While finding the structures, should we remember both the expected one and the result, or just the result is enough?
Actually, if you know how many pairs of electrons, you will know the expected, no?
Yes, Auntie. It's
so
the
that is known already. But you have to know the actual shape observed.
Oh, yes.
Actually, learn it thoroughly. Write and learn. Don't assume that you can read and see and go. No, don't write out of memory. Each one, write and learn. Thoroughly perfect it. Because unless you perfect the syllabus given, you cannot learn extra. It will go above your head. If you are very thorough with the given syllabus, then only you can work on yourself and you can learn more. Is that very clear? Because I keep telling you this, no teacher can give you all the information. I cannot claim that I will teach you everything so that you can clear your NEET or IIT. No teacher can do that. It is your own effort. Completely it's your own effort. We can only help you to understand the basics thoroughly, so that based on that you will have to learn more. Okay, so I'll read out the in-text questions and we will learn. Why is helium used in diving apparatus? Why it is used? Because helium has got low solubility in blood than nitrogen. Okay, it has got low solubility in blood than nitrogen. So a mixture of oxygen and helium is used, because when they come out at pressure, blood will absorb that. But when they come out, when the pressure is less, they have to release that. When they release, it is very painful if they have inhaled only air. So many problems used to occur. Earlier they didn't know. They just carried air and cylinders, and they used to suffer a lot. Now they know that it causes bends, so they mix helium now, so that they will not have any problem when they come out, when there is less pressure. Okay. Now balance the equation. XeF6 plus, write down, balance the following equation. XeF6 plus H2O, XeF6 plus H2O, giving XeO2F2 plus HF.
And it 2H2O and 4HF.
Correct. Excellent. 2H2O and 4H. Easy they have given. But they may give you tougher one, that XeO3 one. That is 24 and 12 and all that. Okay. Now, next, last question. Why has it been difficult to study the chemistry of radon? Why can't you study the chemistry of radon? Because radon is radioactive with a very short half-life, 3.82 days. So it is difficult. Okay. So it is difficult because it's a radioactive element with a very short half-life. So it is very difficult. By the time you study, it would have decayed. So it is difficult to study. I don't think they will ask such simple questions, stupid questions. Definitely they'll ask you some structure or balance the equations or something like that. Okay, learn all the things thoroughly. I will send all the notes complete. I think from where I have to send? Last, I think in interhalogen compounds, I think so. I think interhalogen compounds.
In the last I wrote oxoacids of halogens.
Oxoacids. So interhalogen compounds I have to send. I will completely send it now. Complete the notes. Learn it thoroughly. I want to revise it, but I will revise after completing the first term portion, because I am more interested in first finishing the portion. You keep studying. You do your work and keep studying. Whatever I have sent the notes, complete the notes and keep studying. But I will revise it after I complete the first term portion. But next Wednesday I will start with solid state.
Okay, Aunty.
Start with that, and then organic, if I finish, I'll start with biomolecules, so that we'll be covering everything. If I complete any one of those, I will start with the revision.
So, Aunty, next class is on Monday, right?
No, Friday it's a festival for us. So next class is on
Okay.
Monday. We'll do workout problems.
Okay.
Okay?
Okay.
Okay, pa. Have a nice evening.
Bye.
Bye. Okay, now what I have to do, I have to go to drive. Then after going to drive, I'll go here. I'll go to this account. First I'll go here and